Right. So I was saying about how yesterday we went more into the differences between what a data model is and what a schema is, and we found they are quite very similar in their usage, in the way that we throw them around. People tend to use them interchangeably, but on a more deeper level, we realize that schema is more of a machine language, you know. So how your tool, in our case now, Power BI, how it interprets the data to do the coding and computing behind the scene, that is more what schema is about. Whereas the model itself is how you, as the analyst, have arranged your data set, the tables, how you have arranged, things up in such a way to make analysis and business intelligence easy or doable. That's what a data model is. And that's the major difference between the two. But the differences are not that much, okay? And we did remind ourselves of why there's a need to actually do your data model. Yesterday, we did a quick drawing up of these charts, which we picked from the different tables, for this particular chart of products versus price. We picked price from the orders table, and we picked product from the products table, two different tables and two different columns, and we were able to form this. Same goes for customer table and orders table for how we sliced between customer and price, or the sales amount that we got, and we went further to create this slicer, which is used for filtering. It's called slicer, and when we operated our slicer, we can see that when we pick Birmingham, we see that customers from there are two, Sarah and Ahmed, and we got this. This is the sales, the products that we sold in Birmingham, and for Leeds, this is what happened with Leeds, and for London. So we are able to get the different interaction, between our slicer and the two different charts at the same time. And we said the reason that is happening, the reason that is possible, is because of how we have created the connections, the connectivities that we've made to happen between these tables. Yesterday, I remember that we went on to delete this relationship between product and orders table. And immediately we did that, let's delete that properly. Okay, it's working on it. So that connection is deleted, no communication is happening. And this is what we found happening to the visual, okay? So we're not getting a true picture of things anymore, okay? Even the slicer is not working with it as it should, Okay, actually the slicer is working with it, but that's not the way it should work. It's just giving us a total for what was gotten for everything in Luton, everything in London. It's not splitting this particular price into the different products level that we have. And each time you create a visual or a chart and you are getting this type of reaction, straight on, you would know that, or you should know that that is a data model problem. Okay. And how to fix that is to come connect what we disconnected, which is drag products back from one table to the other, and we form it brings this box for us. And let's talk about this box for a second, okay? So from the table products, this is the only column we have in product, and it's already highlighted that. And the other table is others table, the second table rather. That has been picked here as well. If I click on the drop down, you can easily see other tables that are within your within this report, within your data model, okay? And if I scroll to the right, we see product is highlighted for both tables, meaning the relationship is happening, you know, on those columns from the different tables, okay? Then we go on to where it says cardinality, you know, and cardinality simply means relationship, okay? So right now, it's telling us that the relationship is one to many. That is, we are looking at one side of the table and joining it to many sides of the table. If I click on the drop down, there's quite different types of relationship that we can see. We see many to one. Many to one and one to many are basically the same thing, okay? It's just the direction of flow that makes, like, you are going from the facts table to the dimension table, or from the dimension to the fact. But basically those two are the same. And that's what we normally would aim for when we are creating our relationships, okay? Then we have one-to-one, where both sides of the tables or of the schema are appearing as one. And then we have many-to-many. We try to run away as if we can help it. We try to desist from using one-to-one and many-to-many. There are times that you can't really run away, okay? But as much as possible, you go into this part with the aim of creating either many-to-one or one-to-many relationships. And we look at the cross-filtering or cross-filter direction. How are these two filtering each other? It is filtering in one single direction. Sometimes where the need arises, you could need both, okay? It seldom happens, but when you need it to happen, then it needs to happen. Okay, so let me drag that again. I forgot I was creating a relationship here. So we just, and make this relationship active. Sometimes you create relationship and you don't want it to be active for whatever reason. There are reasons why that can happen. But right now we need this relationship to be active. So we save that, you know, and immediately we are able to create or recreate that relationship. We have the problem with this visual got solved or gets solved. Okay, so a lot is dependent on your data model, okay? A lot is dependent on your schema, okay? And it's like the backbone on which all the analysis you are gonna be doing, okay, is gonna rest on, okay? And yes, again, yesterday I was discussing trying to explain about how if we go into our Power Query, we go into the Power Query, how we started with just the one table. We started with others table, just one large, you know, we have a small data set, but here, let's just say one large, you know, data set where all our records have been gathered, you know. And we went on to do what we call decentralization. We decentralized this data set by creating the dimensions, you know, that we need out of it. That's called decentralization. And someone would argue that what's the point of, you know, making it into 4, 5 other tables or 4 other tables when we can just work off this one, okay? For a small data set like we currently are handling, yes, we could actually get away with that. But where we are having tens of thousands of rows of data, the best practice is to decentralize your data. That is to reduce the top one, the large data set, single entity data set that you were gonna work with and create smaller chunks from it. Okay, that should, in actual sense, reduce the fact table that you started with. Okay, I went on to, because I wanted to get a full explanation for us. I went on to ask, and I have asked this before, I just forgot what the full explanation should be. So I've gone on just a few minutes before class to ask it that when we have a flat table, like what we started with, you know, in this data set. Okay, can we hear me? It's telling me my internet connection is unstable. Am I still in class?
Yes, we can hear you.
Okay, thank you.
Or rather, I can hear you.
Yeah, well, if you can, I'm sure others can as well, except their internet is having trouble as well. Okay. So I was asking it that when you have a flat table to analyze, why is decentralization necessary? And like I said, decentralization is when the way we chunked, you know, the actual data set into different dimension tables. We created other tables from it. That is, it was the central table, just that one. We decentralized it by, you know, getting some of the attention away from it, creating other tables from it. And it's telling us here that, great question. This goes right to the heart of a good data modeling and why we don't just analyze everything in one big flat table. This is the reason why, or these are the reasons why it's not the best practice to just get a flat table and that's it, especially if it's a large data set. You can get away with it with a small one, like the one we are using is quite very small. Okay. Now, says a flat table is one large table where everything is stored together. You have all your facts, all your descriptions, and all of them, or most of them, are repeated. A lot of, you know, rows are actually repetitions. Example, order ID, customer name, customer city, product name, product. So all of the information about the order, about the customer, about the product, about the suppliers, everything would be in just one table. Okay. So as time goes by, as your data set grows and is becoming hundreds of thousands, 200, 300, 400,000, that is not right. It won't be right to analyze straight away from it anymore. Okay, so why decentralization, or what we call normalization? Okay, dimensional modeling is necessary. Okay, the type of model that we built, apart from it, from the schema's perspective, it would be called a star schema. But from a data model perspective, it's actually a dimensional model that we built. Okay, I'm hoping that those technical jargons are not, we're not getting confused by them. Okay, well, these are the reasons. It avoids data duplication. Okay, what does that mean? If we go into here, within the orders table, a lot of data duplication can occur. Like we said, from the angle of the customer, customers can come and place orders 10 times, 100 times, however many times. And that means city would occur as many times as possible. That means the same phone number would occur so many times, you know. That means the same laptop, the same product would occur very, very repetitively, okay? But we've gone on to create tables that actually store the unique values of each of these different columns or dimensions. So we now have a customer table where none of it is repeated. So for our own sanity, we can easily come here and look up, you know, and get information about our customers. Same with the rest, you know. That is one reason why it's necessary when working with big data to avoid using just a flat table, okay? So it avoids data duplication. That is, it's reducing redundancy, okay? London might appear thousands of times, save customer details repeated in every row. This wastes storage and creates inconsistency risks, okay? You won't quickly capture if there's data quality issues because you are dealing with too many columns and too many rows, you know. With decentralization, that is the way we have created further tables from one, we have been able to separate into tables like customers, like we have in our data, products, you know, then we have location and so on and so forth. Depends on what your data set is talking about. So London, which would have appeared in that one big flat table like 10,000 times, when it gets to location table, London would only appear just once. So that is you actually making sure redundancy is dealt with, okay? It also improves your data integrity and accuracy. So in flat table, if a customer changes address, you must update it in every row. Thank God Power BI makes that easy, okay, to do. Power Query rather makes it easy to do. But if it were to be a hard bone to crack, then it means you will go into tens of thousands of rows where the customer name has appeared and be looking for how to update it. But if if there's any, Sister Badebokola, you're typing on our screen. So if any changes occur, you can easily just go into the one table where values are unique and just go in there and just change, very easily change up or update. Sister Adebukola, check your phone. You are disturbing the flow of our class. So you are writing or squiggling, Denny. Okay. All right. So that is another reason. Then, yes, with decentralized structure, updates once in customer table, everything will stay consistent. Like we said, you can easily capture data quality problems when you decentralize. Also for better performance for your analysis, especially in tools like Power BI, in any business intelligence, not just Power BI, any business intelligence tool, SQL, you know, whichever one, okay? It is it's relevant to us as data analysts. You know, flat tables become very wide and heavy over time. And as they become very wide and heavy, they become very slower to refresh. You know, sometimes you open a report up and it's taking forever to open because of how big, how large a particular table or even all of the tables how it's been made, okay? So most of the calculations, queries, measures that you have done in it, they will all run very slow, you know. That cannot be right, okay? But decentralizing means that you are improving the performance of your report, basically, okay? So in decentralized data, e.g. star schema, like we have so again, we'll keep referring to this schema and data model. In terms of schema, what we have created here is a star schema. In terms of data model, it is actually called a dimensional data model, okay? When we go through the slide, we'll see the different types of data model and how they are relevant to us. But yeah, back to what we are learning. So fact table is in numeric, where you get all your figures that you are trying to analyze. And the dimension tables are the descriptive, the customers that, you know, give you more context to the sales figures, you know, up there, or the products or the suppliers or whoever or whatever it is, you know, that your data set is telling you about. So tools like Power BI are optimized for this structure. Fast faster filtering, slicing, and aggregation, okay? Because of decentralized structure that we are working with, you can easily just open, I know we are working with a very small data set, but even if it were bigger than this, the fact that we've done this part right, you know, means you just within milliseconds, you are quickly getting results. You know, before you click, you are quickly getting result. You know, you're not you're not stood before your stakeholders and you're waiting minutes and, you know, for these to work well. Okay, so it enhances optimization, basically. Then it enables flexible analysis. So with a flat table, it's harder to reuse data across different analysis. It's limited in scalability or scalability. But with decentralized model, you can slice data by customer, by region, because you have decentralized into customer, into region, and all of that. This is what makes dashboard dynamics powerful. What that means is dashboard dynamics in terms of interactivity, what more you can do with it, with your different dashboards, you know, how you can easily, you know, jump from one to the other. That the beauty of it is from the fact that you're working with the right kind of schema or the right kind of data model. Okay, this is important, you know, because it's not enough for us to just bring data sets, jump on Power BI and just, you know, quickly create something. It's good to understand the why behind what we do. That's where the understanding will come from. And when you understand what you are doing, whatever work throws at you, chances are that you will be able to face it and overcome it, you know, and interviews you would easily scale through, you know, because you actually understand the backbone of what you are actually, of what data is actually about. Okay, so it simplifies maintenance and scalability. The more your data grows, the less worry you would have. Okay, the more it grows, the more you can do a lot with it when you decentralize. You know, flat table, any change equals risky and complex, but with decentralized table, all you may need is you just need to add a new dimension, maybe create, you know, another supplier table without breaking anything at all. So it's easier to extend your model, okay? And it supports clear business logic, you know. So this links to the earlier discussion, okay? Business logic around fact table being the measurable data and dimension tables being the descriptive. Okay, so this decentralization enforces this separation, making your model cleaner, easier to understand, easier to explain to stakeholders. Okay, so to round that up, we're saying that in simple analogy, we think of a flat table like one giant spreadsheet with everything crammed in, whereas decentralization is like a well-organized filing system. So instead of cramming everything into one large sheet, you've you know, created a system where you filed, you know, like your file cabinets. The top layer is for this, the second layer, and you've labeled them all right. The second layer is where you keep so type of data. The third layer is where you keep, you know, so type of layer. So a well-organized filing system where each folder has a purpose and links to another. That's very important. There must be links within your, that's why it's called a relational database. It's relationship within the database. So when flat tables can be okay, it's not that you must never work with flat tables. When you're working with small data set, for example, our data set that we have been using is quite small. We could have just done everything on this one table and we would have gotten away with it, okay, because it's really very tiny, okay. But I went on to decentralize because we will see it would, I feel it would be more understandable. It would be far clearer when you look at things with a small data set, so that when you are using the same principle with a larger data set, there will be no problem in comprehension, in your own comprehension, because it's what we do with this that we're going to be doing, apart from if there are a different data quality issues that we would need to deal with in other data sets. Aside that, this is how the process that we have used is how we would normally follow. The steps is what we would normally follow to actually create a report in Power BI. Okay. And finally, what is it saying here? So to be balanced, small data set, yeah, when you can use flat table, quick one-off analysis, or when you want to export files. But for actual reporting, dashboard, scalable systems, decentralization is the standard. Yeah, I kept saying best practice, but standard practice is the right word that I should have used. Okay, so decentralization is necessary because it reduces duplication, improves accuracy, it boosts the system's performance, enables flexible analysis, makes models scalable and maintainable. Okay, so that is the reason why we had to create those other tables. Creating those other tables when you are creating your data model, that is called decentralization. That is, you had a central data set and you decentralized it, or you normalized. It's also called normalization. Okay, so do we all understand this bit before we move on? Do we all understand the reason why we don't just work off flat tables, just that table and just keep working on it? And do we all understand the under what situations you can actually, use flat tables? Any questions, please? Let's hear it. I want to hear what we understand. Okay. I want to hear what our understanding of this bit is before we move on to measures very quickly. Anyone to help us out? I need help. Or okay, let me call people. If you are not able to unmute, let's just drop a chat or drop your answer in the chat. Okay, I'll start with Abimbola. Abimbola, are you able to tell us your understanding of why we decentralize, or what decentralization is, or why we decentralize flat tables into data models, into 4 different tables, basically? Abimbola, are you able to unmute? Mr. Victor, are you able to unmute?
Yeah, I can unmute. What's the question again, please?
Yeah, question is, why don't we normally work off flat tables? Why is decentralization of flat tables necessary for reporting?
Oh, okay. So I think you mentioned that it's good for scalability, and because a flat table it's more like one big table that has all the data mix. Okay. So you need to break it into parts, I think dimensions.
Yeah. Thank you. Yes, absolutely. We break our one flat big table into different dimensions and create data model with it, basically. Dami, are you able to unmute? What's your understanding of what we've learned about not working off just flat tables and decentralizing our flat tables? If you can't unmute, drop us something in the chat. Dolapo, are you able to tell us your understanding of the class so far? Or why don't we just work, straight on, start our analysis using just the one big flat table that we have? Why do we break flat tables into different tables? Okay, Staff Felicia, are you able to unmute and tell us?
Why Mike?
Okay.
Okay.
You Bitibao.
As in, I'm supporting now, sister.
No, you are not supporting though. Why are we not using flat table? Why are we decentralizing flat table?
Is it for cleaner and faster data model? As in,
Thank you.
Yes. Sister, take your time. All right.
Yes, it's for cleaner. Yes, it improves our data accuracy, data integrity, better performance. Okay. Yeah, no, I'll be unmuting people and asking questions now. So I know that we're actually doing 30 Beleje. We actually, 30 Beleje in. Okay. Grace, are you able to unmute? Why do we decentralize? If you are not able to unmute, you can drop something in the chat. Ifeolu, are you able to unmute? What's your understanding of why we actually had to break our others table into those different tables, which is called decentralization? Casey, are you able to unmute? If not, let's have your answer in the chat. Yinka, are you able to unmute? Stabola, are you able to unmute? Okay, we've got Dami's answer. I thought somebody was unmuting just now.
It was I, but since you got an answer.
No, yeah, I don't have an answer. I don't have an answer.
It's my first class, so I'm still learning. I'm still trying to figure out. Thank you.
No problem at all. It's good to have you in class today. Okay, so to reduce data duplication and inconsistency, yes, that's just one. Okay, to improve our BI performance, there's quite a lot that we have in the past, 40 minutes or so been, learning from chat. I'm asking these questions so that I can be sure that we are engaging. It's necessary for me to get that feedback. Just in case my method is not working, I can change it to another method. Stashade, are you able to unmute, ma? Okay. Now we do have an assignment about measures. Thank you, Casey. It's hard to manage when it's a very large table, so it's also easier to manage. So sorry, I was a bit. Okay, well, your answer is getting there. I actually love the first part of your answer. Okay, large data sets are not easy to manage because they are large. But when you break out a few columns of them, then those columns can make that data become more manageable. Okay, so you're on the right track with that. Let's be, for those who joined late, we've got We've got the attendance sheet. So let's try and sign in that we were in class today. Okay. I was going to say that I need us to get used to the fact that I'm going to be calling us to answer questions. So, you know, we are going to be answering questions in class. So that it's not just all quiet. Yes, so the second part, decentralization makes it easier to manage. That's correct. Thank you very much. Decentralizing your data is when you break it into the different dimensions, you know, that is necessary. And decentralization helps you to manage the data more accurately. It makes reporting more accurate. It improves integrity of your data. It helps BI tools for better performance, okay? So amongst other things that, you know, it removes duplication of data, you know, duplicity that is removed. We have seen these things when we actually worked on this data set, okay? We have seen this before, okay? So I'm going to close and apply this. What did we find out about measures? What are measures? That's the assignment. And that's where I should have started from, to be honest. What are measures? What did we find out about measures? Any answers? Or should we repeat the assignment? Let me have response, please.
This yesterday we were not really clear with this, you know.
Which one?
As
What
in
are-
yesterday we were not coordinated in that class, so this assignment may have to be
Okay, so we should rethrow it
retro to
to
Sorry, Sister Ishodi.
yes, ma'am.
Sorry, I didn't know that I was muted. Mention, sorry, ma.
fantastic. We have answer.
Oh God.
No, I didn't have answer, please. Measures, anyway, in our own layman, they are just calculations made within the Power BI. They are groups of aggregates that can be performed.
Yes, absolutely. Thank you very much. Ade has rescued all of us. She has rescued all of us. So I
God
won't
bless
be,
you.
I won't be
They
destroying.
are artificial made calculations.
That's correct. Yes.
Expressions.
Yes. So thank you very much, Ma. You see, let us be doing all these researches. It will help us. Okay. So the
Ishodi, I'm repeating the class.
no, but at least you are showing that you have been in the class already. You know, so yeah, the measures that we were told to research, measures in Power BI are calculations that we'll start to, you know, make or calculate. They are artificial calculations, yes, because you are the one calculating or making those calculations. They are aggregates, yes, they are aggregates, okay. You see the way that when I was going to create this visual, all I did was just drag price from here, from the table itself, you know, and I just dragged price in and quickly, you know, created that. Well, that's not a good practice, okay? Good practice or standard practice is that I create all of my aggregates as measures first, okay? Measures are actually like virtual calculations. They virtual because they don't really take up space in your model. So by the time you create as many measures as possible, they are there but not there. It's like the way we are having this meeting. We are not in a particular location in a physical class having the meeting. Okay. The same way that measures are stored in your Power BI. So how is it created? Let me see if we can use a few 2-3 minutes to quickly look at that. Okay. Now, if we pick any table here, okay, best practice is to always create a, okay, let me create a table for it actually, where we'll be housing the measures that we create. So all I've done, let me cancel that. All I've done is gone onto this enter data under home. It's also probably under modeling, I believe. Or yeah. Okay, no, it's not. It's here somewhere. Okay, it's under home. You can get it when you are on this particular, on the report view or on the table view. Okay, so this table with a plus at the corner of it, left hand side corner of it, that's the enter data. That's how one way to create tables in Power BI. Okay, we are going to name this table measures. Okay, and this is where all of the measures that is created is going to be housed. Okay, so I load it. Okay, and it's going to join all the tables on our right hand side. It's going to become one of them when it's completely loaded. Okay, so can you see it says measures here? Okay, and it's only column 1 that we saw in it earlier. That's the one that there is. For now, we haven't put anything there. Okay, so each of these tables, when you hover on them, they have 3 dots on the side of them, 3 dots. And when I click on the 3 dots, it opens up these different functions: new measure, new column, new quick measure, refresh, and all of that. Okay, so our new measure, I'm going to go into the table that we just created and called measures. I'm going to hover on it and click on those 3 dots, okay, and say I'm creating a new measure. Immediately that happens, you see our formula bar here opens up, okay. So rather than me, picking price from other table when I'm needing to use it in any of my visuals, I'm going to create it as a measure, as a virtual calculation that is here, okay. Total sales. Let's call it total sales because price is just sounding somehow to me. Okay, total sales. And it's the way you use it in Excel as well. Okay, immediately you give what the name of that measure is going to be. I'm going to create total sales equals, I want to aggregate, that is sum up all of those price in that column. Okay, so after equal to, like in Excel, I start to press sum because I want to sum up a column. Okay, so immediately I start to press S, all the functions starting with S start to come up. Okay, that is necessary. The IntelliSense is sensing that you're trying to get a function up. Okay, so sum. Okay, I picked sum. Okay, and immediately I pick sum. Can you see a dialog box up there, like you would have in Excel? After the sum, it's prompting you to put the column name. What column are you trying to sum? And then close the bracket. The bracket has been opened here for you. Okay, so, and I want it from orders table. So I can scroll down, or I can just start to type orders, and it brings all of orders. Orders table, or everything that starts with O within my data set. Okay, in this case, it's just orders, and I need price. I'm trying to sum up this price column. Okay, I click on that and I close the bracket. You can press enter or the green check there to commit it. And there you have it. You have just created total sales, or total price, total amount. See, and when you come into the measures table, that is now there, total sales. Okay, so to validate that and just be sure that it is correct, I can pick a card visual. Where is my cards? Like all the cards have disappeared. Though. Help me out, people. I can't see card visual here, which is, oh, there it is. Okay, so I just, pick on the card visual and check that I've got value. Oh, okay. So my total sales, 3.48, 3.48K. If I click on that and see what more I can do, it's in currency, when I clicked on that measure, this part opened up and it's telling us the name of the measure is total sales. The home table where it is housed is called measures because it is housed within the measures table. Formatting of it is in currency, okay? It's comma separated, if I want to change the number of zeros, the number of decimal places, I can change that, and so on and so forth, okay? But that shows me that all of this, if I go into the orders table, you see all of this price here, if I add them all together, it gives me, this is what they give me. Again, I can decide to quickly aggregate. Aggregate means you are summing or you are making a one, either summing or averaging, or multiplying, whatever it is, any mathematical, calculation. Most of the time is an aggregate, not all the time, but most of the time. So I'm quickly creating another one. That same table is what I want to use. I click on the 3 ellipses again, new measure, and this time I want to calculate the total quantity, because we have quantity as well. Total quantity of the products that we have sold. Okay, quantity equals, immediately I put equals and I'm gonna sum up, okay? And it's within the orders table. So I put an O, an orders table, and there we have quantity. I pick on that, okay? You can press enter or commit it, okay? And there we have it. That is also created. I pick another card visual, just to be sure, okay? Gradually, we are actually creating our KPIs, okay? Yeah. I can decide that I want to count the total number of transactions, all of these transactions, all of these orders that we have had in orders table. I can decide to count how many transactions happen by counting, the orders or the table. I want to see, let's count rows, okay? So how many transactions did we happened within the time? Okay, so again, I'm going to create that as a measure, and total transactions is what I'm going to call that. Okay, because this time around, I'm not going to use sum because I want to count. So, and I'm counting rows. Maybe I start to type count after the equal to sign, all of the different count functions come up, and I can pick the one I want. I want to count rows, the rows in a table. Immediately I picked count rows. This dialog box opens to prompt me that which table do I want to count the rows of, So you start to put the name of your table, and it's the orders table, okay? I close the bracket, and just to validate that, normally I validate using checking here, okay? Sometimes you may need to open up Excel just to double check, your work. It says 12. If we count the total number of rows, thank God this is a small table, it should be giving us 12. If it's not giving us 12, then there is trouble. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. okay, because we have a double duplicate, 102, 102, that's why, because I see 11 there, but there's 12 transactions, okay? So 12 transactions, with 12 transactions, we sold 18 quantities of products, for this amount, basically. If there was profit, if there was cost price, we will also quickly run a total of those. And this can, these serve as our KPIs to show how we are performing as a business gradually. Okay.
Please, we have 5 more minutes, okay?
Yeah, oh, no, we are going to round up now. Thank you very much for the reminder. And again, these slicers, the slicer still works. So if we look at Birmingham, we can see this is how much we made in total. We sold 4 quantities in 3 transactions. Okay. In Leeds, that's how we have it. In London, 3 transactions, gave us those, and 4 quantities of products. In Luton, we have just 1 transaction. In Manchester, we have that many. Okay, so today we've been able to look at why we decentralize data. That is why we started with 1 flat table and decided to break from that same table, other different tables called dimension. Okay, we've also just brushed a bit on schema and data model, basically. Okay, and we've seen what measure is and how simple measures, these are simple calculations, simple measures are calculated. Okay, from the simple measures, we can build on, more complex ones. You might want to look at total quantities for previous year, if your data set is a whole year, for 4 or 5 years data. You may want to compare previous year dynamically and current year. There's a way that you will make the calculation to say that every time the year changes, I don't need to come back and put 2025, 2026, 2027. I'll just use a dynamic calculation that, states that previous year, this is how much we are making in the dashboard. Current year, this is how we are doing, and so on and so forth. I hope with these few points of mine, I have been able to convince and not to confuse you